Hello Year 7, today we are going to carry on with the same format as last lesson. This lesson we're moving on to prime factor trees. Now I know last lesson probably had a lot of sections for you. You may or may not have gone through all of it. I'm going to try and recap as much as I can as I go along. There's also an exit ticket at the end of this lesson, so wherever you get to, even if you don't finish everything in the whole hour, what I would really like you to do is make sure you allow 5 minutes at the end of this lesson to do the exit question and then submit that to me on Show My Homework or email me. It's really important that you do that because it allows me to work out where you're at, help you if you're still stuck, and I can amend future lessons so that they are more targeted towards you. So it's really helpful, and I'll give you some feedback on it for next lesson. Okay, so if you want to skip around between the explanations, all the timings are on Show My Homework, so let's get going. Okay, so we have a do now from yesterday's lesson, so it's recapping what you did there. So there's listing some factors, writing multiples, what's the first prime number, what's the third prime number, so just see what you can remember, but also you have your notes there, and please do use them. If you finish those quickly and you find them a bit easy, there's a couple of challenge questions at the end there. Okay, so mark your answers. Pause the video if you need to. Remember, factors are numbers that multiply together to create another number, or another way of looking at it is they divide into that number and you get another whole number out, and multiples mean times tables. 2 is the only even prime number. Okay, so that's worth remembering, and 1 is not a prime number. Remember, it has only one factor, and our definition of a prime number is it has exactly 2 different factors, 1 and itself, whereas 1 has one factor, 1 is itself, so it's not a prime number. So I'm going to go through some keywords that are going to be very important in this lesson. Okay, so our objective is to be able to write any number as a product of its primes. What I mean by that is prime factors. So please copy down these definitions. It's really important you're very clear on all of these words, otherwise what we're doing next won't make sense. So prime number has exactly 2 different factors, 1 and itself. Product, so writing as a product of its primes. In maths, the word product means multiply. Just as sum means add in mathematics, product in this scenario means multiply together. Factors are whole numbers that multiply together to make another number. Okay, so you could say the product of 2 numbers multiplied together create that number, those factors. We can write any number in our number system as a product of its prime factors. So we can write any number in our number system as only prime numbers. So that's really important, and we're using that fact to solve problems in later lessons, not today's lesson. So we're just practicing a skill in today's lesson. For example, 2 times 3 times 7 is 42. We could write just 42, or if we wanted to write 42 as a product of its primes, we can write 2 times 3 times 7, and that is the same thing, they are equal. So last lesson, not all of you will have got to this question, and there is a way we can work out what our prime numbers are, so long as we remember our key definition of what a prime number is. So it has exactly 2 factors, 1 and itself. Okay, so we said 1 is not a prime number. So using this grid, we can rule out numbers that we know are not prime numbers because they're multiples of numbers we know are prime numbers. So first of all, I'm going to cross out the number 1 because 1 is not a prime number. Now the next number in my list is 2. Remember, 2 has exactly 2 different factors, 1 and itself. Its factors are 1 and 2, which makes it a prime number. Now 2 is the only even prime number, which means any other even number in our number system will not be a prime number. Okay, 2 is the only one, and it is the first one. Therefore, using this grid, we can cross out every other even number. So we go through and we get rid of all of our even numbers through here. So if we do this, no even numbers are left. Okay, so The next number we're looking at is 3. Now 3 only has two factors, 1 and 3, which makes it our second prime number. Now the same way that 2 is the only even prime number, 3 and is a prime number, which means any multiples of 3 are not going to be prime numbers. So we've already crossed out 6, so our next multiple of 3 is 9. We can cross that out because 9 is 1 times 9 is 9, 3 times 3 is 9, so there are more than two different factors. Okay, so we're just going to cross out any other number in our 3 times table and we're left with these values. Next, so we've already crossed out 4 because it has 2 as a factor as well as 4 and 1. The next number is 5. 5 is a prime number, 1 and 5 are its only factors. That means we can cross out any other number in our 5 times table in our grid. Okay, so we're just going to cross out that whole column there. Okay, so the next number that we haven't crossed out is 7. That is also an example of a prime number. Any other number in the 7 times table after this, any other multiple of 7 is not going to be a prime number. So we can cross all of those out too. And then we'll look at 11. 11 is a prime number, only factors are 1 and 11. So we cross out anything else in our 11 times table. Okay, so once we've worked through all of our prime numbers on the previous slide, we can see that we're left with just these values here in purple. It's really important that you try and recognise and become very, very familiar with these numbers because that's going to help you with prime factor trees and prime factorisation. Okay, so remember 2 is the only even prime number, your second prime number is 3, your third prime number is 5, your fourth is 7 and so on. Okay, so try and recognise those at least up to the first 2 rows if not further. Okay, so I'm going to do a couple of examples of what we're going to be focusing on for the majority of this lesson. So on the left we have an example and we want to express 30 as a product of its prime factors. So the way we are going to do this is we're going to break 30 down into a prime factor tree. So first of all, I'm just looking for any two numbers that multiply together to make 30. And I might think, well, I know that 2 and 15 multiply together to make 30. So the branches on our factor tree multiply together to make the number above. Now 2 is a prime number, so what we do is we circle our prime numbers, and these are the ones that are going to make up our prime factorisation. 15 is not a prime number, so we're going to break 15 down into a pair of numbers that multiply to make 15. So we might pick 3 and 5. So 3 times 5 gives us 15. They multiply to make the number above. Okay, so 3 is a prime number, so I'm going to circle that. And 5 is also a prime number, so I'm going to circle that. So once all of the branches in our tree are comprising only of prime numbers, we can write our product of primes. So we can say 2, which is our number in our first circle, multiplied by 3, multiplied by 5 is equal to 30. And you can check that. 2 times 3 is 6. 6 times 5 is 30. So writing this number as a product of primes, this part here is our answer, and we use our prime factor trees to work this out. Okay, so pause the video if you need to make some notes, rewatch it if you need to, and then what I would like you to have a go at this question on the right here. So pause the video and have a go at this question before moving on. Okay, so hopefully you've paused the video, you've had a go at the question and got an answer. So I'm going to go through this. So we've got 60 here. What we're going to do is break 60 down into two numbers that multiply together to make 60. Now what you'll notice when you're doing these prime factor trees is it doesn't matter which numbers you pick. There is only ever one solution that you will get down to for prime factors and writing numbers as product of primes. It doesn't matter how you get there, so long as your method's correct, okay? So this time I'm going to choose 6 and I'm going to choose 10. 6 times 10 gives me 60. Great, neither of these numbers are prime numbers, so I'm not going to circle either. 6 will break down into 3 times 2, and that 3 times 2 is going to give me 6. Okay, so both of these are prime numbers, so I'm going to circle them and I'm going to stop going any further because they're both prime numbers. Then I'm going to look at my 10. I'm going to break this down into 2 and 5. So 2 times 5 gives me 10, which is the number above. Both of them are prime numbers, so I'm going to circle them. Okay, so really important that you write the numbers in order of smallest to biggest. So I've got 2 times 2, these are my smallest numbers, multiplied by 3 and multiplied by 5. And we can say that equals 60. So the answer is this bit here. We could also write that as 2 to the power of 2 multiplied by 3 multiplied by 5, which is the same thing, but where we've got a number multiplied by itself, we can write that as a power. So 2 times 2 is the same as 2 to the power of 2. Now, when we look at the difference between these two questions, 30, to get from 30 to 60, all we're doing is multiplying 30 by 2. And what you might notice about your prime factorisation is in your answer, this 2 is reflected here. So everything here is exactly the same as it was here. 2 times 3 times 5 is contained in 60, but 2 times bigger here. So that's worth keeping in mind, although not essential at this particular point. Okay, so pause the video if you need to take notes, rewatch it, otherwise we're going to go on to a practice exercise. Okay, so in this exercise you have a table. What I would suggest doing is copying this table onto some paper, and what you've got here is numbers at the top. What it wants is prime factor decomposition, so that's the numbers multiplied by themselves, and index form. And so index form means powers. So you want to simplify your answer, so you've got things turning up as powers. And you've got an example of that here. Okay, so look through the table. Your prime factor decomposition is going to look like this, and then your index form is probably your challenge. So you could just start by working out what 2 times 2 times 3 is in your second row, where I've starred, and writing your answer here. Then 6, you're going to draw some factor trees. So I would do your workings on a bit of paper on the side. Okay, so just pause the video now and work through those questions. Obviously you can skip ahead and check the answers as needed just to make sure you're on the right lines. So try and complete that table. Okay, so please mark your work, pause the video as needed. Hopefully you had some success with this and are ready to move on. But if not, maybe just go over the explanation from before and see if you can correct your work. Right, so here's another exercise. This exercise is a little bit different, so it's just checking your understanding of product of prime factors. So I would start over here and work through the column this way. You're looking to say whether this sum here or this sum here and this sum here and so on are a product of prime factors. So if you need to go back and revisit the definition of product of prime factors, that's fine. Just pause the video now and have a go at these questions. Okay, so hopefully you worked through all of these, and now I'd like you to mark your work, pause the video as necessary. Now remember, 5 plus 7 is not a product of prime factors. You're adding numbers together, and that is not the definition of product. So we can say in this first one, no, it's not a product of primes. In the second one, 5 multiplied by 7, it is a product of primes because product means multiply, okay? This one here, 4 is not a prime number, therefore this is not a product of primes even though you're multiplying. This is a prime number, this is, and this is multiplied, therefore you can say it's product of primes. This one here is, they're both prime numbers. This one here isn't, because 1 is not a prime number. Okay, so anything that multiplies by 1 or anything that adds is not going to be a product of prime numbers. Later examples where you've got powers are absolutely fine, so long as the numbers with powers are prime numbers. Okay, so you've got 1 is not a prime number here, therefore we can say this is not a product of primes, even though 7, 11 and 31 are prime numbers. Okay, so I'd like you to look at these values here. We've got 18, 90 and 180 broken down into product of prime factors. And this relates to our original examples. So we had 30 and we said that 30 is 2 times 3 times 5. And when we did our factor tree for 60, we saw that it was 2 times 2 times 3 times 5. And we said, actually 60 is 2 times bigger, and it still contains this core part of 30 as a prime factorisation, but it also has this. So between 18 and 90, just pause the video and see if you can work out what's extra and what's the same between those questions. Okay, so it's okay if you're not sure about this, I'm just going to go through it now. So to get from 18 to 90, we have to multiply by 5. Okay, so we're going to multiply by 5 to get from 18 to 90. And this additional multiplication of 5 is shown here. 2 times 3 squared is core to both 18 and 90. But we have this additional multiply by 5, so this is the bit that's different. To get from 90 to 180, we are multiplying by 2. So to get from here to here, we are multiplying by 2. And this is reflected in this additional power here. So if we're going to write this in longhand, we write 2 times 2 times 3 squared times 5. So the only bit that's additional is this 2 here. Okay, so we can use products of primes and use numbers that are easy to calculate and work out multiples as well. Okay, we're going to do another example. So we want to express 24 as a product of its primes. So first bit, hopefully you're getting confident with, we're going to break 24 down into 2 numbers that multiply together to make 24. I'm going to use 2 and 12. 2 is a prime number, so I circle that. 12 is not, so I need to break 12 down further. I'm going to break that down into 3 and 4. 3 times 4 is 12. 4 is not a prime number. 3 is, so I circle it. Lastly, I've got 2 times 2. And that makes our 4. Both of these are prime numbers, so I'm going to circle them both and then write out 2 times 2 times another 2 multiplied by 3, and I'm going to say that is equal to 24. If I were going to write that in index form, I've got 2 times 2 times 2. It's 3 2's multiplied by themselves, that's 2 to the power of 3, multiplied by 3, and that equals 24. Okay, so before you do the your turn exercise, just think, how much bigger is 48 than 24? Okay, so you may have realised that 48 is 2 times bigger. And if you know 48 is 2 times bigger, then all you have to do, rather than doing your prime factor tree again, is you can say I've got another 2 and I'm going to multiply it by my 2 to the power of 3, and I'm going to multiply that by my 3. And we know that's going to equal 48. And we can simplify that down then to 2 to the power of 4 multiplied by 3, and that's going to equal 48. Okay, so we're now using our understanding of how numbers are built to skip a little bit drawing our prime factor trees. If this is seeming a bit too hard, please do pause the video and go back, or skip forward to the exit question and then come back to this at the end. Okay, so what I'd like you to do now is have a go at these questions. So we've got product of prime factors. We've got 18, 90 and 180 for questions 1, 2 and 3. So you might group these. You might work out product of primes from 18. You might do one factor tree for 18 and then think, how do I get from 18 to 90? I multiply 18 by 5, so what does my product of primes look like then? So think back to the examples we did and see if you can use your answers from the previous question to inform your answers to the next one. Just pause the video now to work through those questions. Okay, so the first 3 are there as answers for you now. Right, so here are the answers to the questions that you've just had a go at. Don't worry too much if you're not sure about this. It's tricky when you get to year 8 as well, but I wanted to provide some stretch for you today and get you thinking about those numbers. So just mark what you've done, and then the last question is your exit question. This is the one you need to submit to me today. Okay, so this question you have to submit to me today. What I would like you to do is draw a prime factor tree and write 100 as a product of its primes. So just as you were doing earlier on in the lesson, draw a factor tree for 100, write it as a product of its primes. So when you've done this question, take a photo and submit it on Show My Homework or email me and I'll give some feedback next lesson.